Just up there, guys, you see a periodic table. What we're going to be looking at is, see the first column there?
Yeah.
Okay.
Alkaline metals.
They're the alkaline metals, okay? And they are very, very reactive. I'm going to show you how reactive they are, because I'm going to just throw some in water. They react quite vigorously in water. Well, I'm going to start with, I'll start with lithium.
Yeah.
Should I start with lithium? Yes, I will start with lithium. Okay, so, and these are metals, they're all metals, and I'll just show you guys what they look like. They're so reactive, we have to store them in oil, like that. So there we are, this piece of lithium, covered in oil.
Got to cut it.
And yes, I'll show you that it is a metal, right? It's actually quite easy to cut. Okay, it's probably got the consistency of really hard butter. Okay, you can see it there, it's metallic. The reason that it is dark on the outside is because
it's tarnished.
It oxidates. Yeah, it's tarnished. It oxidizes with the air really, really quickly. Okay, so there we go. Oh, so I want to try and get the pieces that's the same. Very easy to cut. What I've just done with the water is I put a indicator. Those who were actually in my class today would have known that this is universal indicator.
What is that?
It changes colour with different pH and alkaline.
Green. Because what was a neutral, isn't it?
What is neutral? Yeah, that's right. So it's green.
So green is neutral, is it?
For this indicator, yes. Alright, so I'm going to remove the oil from it. Also, we'll try and do this as quickly as possible because I don't want to spend too much time. But what I'm going to have to get you guys to do is I'm going to get you guys to stand back a bit because it is an unpredictable reaction. Lots and lots of horror stories in terms of teachers doing this. Lots of things. Last school I taught it is that I had burn marks on the ceiling, on benches, had them everywhere. Okay. People have a tendency to be set alight. Okay, which is not very pleasant. Alright, okay, so this is lithium. I'm going to throw this in water and just observe what happens. So it's reacting with the water, splitting water apart to produce hydrogen gas. You can see the indicator's changing because it's producing hydrogen gas, you're right there. And sodium hydroxide, which is alkaline. Those of you in my class today would know that because you tested it.
We did.
Okay, not very exciting though, is it? It's reacting with the water, fizzing around. That hissing is hydrogen gas being released. How exciting was that? You excited? I was excited. What about?
It was alright.
Well,
yeah.
let's do sodium.
Sodium.
Okay, sodium is the next one down on the periodic table. And I'll show you what sodium looks like. There we go. That's sodium metal. And again, what I'll do is I'll cut it.
So wouldn't there be cross-contamination by using the same thing, the same kind of quizzes every time?
No, they're fine.
Using the same
what
water.
I'm just showing you is demonstrating the reaction with water. This, see again, it's nice and shiny metal. Okay, what I'm sort of just showing you that how reactive it is in water. Oh, that's a big piece, isn't it?
Oh well.
Nothing missed. Nothing missed.
Nothing.
Piece. Okay, got to get rid of the oil as much as I can.
And then back.
I need you guys to stand back again. Do you think this is going to be more or less reactive?
More. Because it's lower down in the period.
You know me too well, don't you? You know I don't start with the most reactive. I build up to a.
Is potassium the most reactive?
We'll find out. Okay, here's sodium. This sodium in water. Bit of steam coming off as well. Really exothermic. Lots of heat given off.
It's turned into a ball.
That's right. Yeah, it sort of reacts. It starts to spin with the gas as the gas gets produced. It's actually right splitting across the water. It's actually sitting on a bed of gas as it's reacting with the water. It's producing the gas. Yeah, pretty much like a holocraft. So it's fleeing across the water at the moment.
It's got nails.
So just be careful, guys.
Oh.
Three fangs at the end.
Is it?
Yeah, there we go. Start the. Oh. Alright, let's do potassium. Potassium's the next one down.
Hey,
So is it true that bottom two you're legally not allowed to have you're not allowed to have unless you're a proper scientist in the science laboratory?
Well, what do you mean to purchase it?
Yeah.
Well, it's a restrictive substance. They all are because you can see they're very, very reactive. Okay, you don't want people actually buying this all over the place and throwing it into water. There are things on YouTube where people have done that, thrown it into lakes, big chunks of it, or swimming pools, and those sorts of things.
What happened?
Oh, you'll have to find out.
It goes bang.
Okay, that's quite a big piece of potassium.
Oh well.
Maybe I should
That
cut
looks
that
like
down a bit.
jelly.
Well, even I'm scared to use that much.
It looks like
Okay.
it.
Again, now as you move down, they get softer and softer. Okay, sodium was like consistency of soft butter. This just cuts like really, really soft butter.
Like
I don't
jelly.
know how to describe that. Very, very soft to cut. Even though it is still a metal.
So is francium so soft it just melts?
I don't know because we
Isn't
we
there
can't
any,
access it. The
isn't
problem with doing francium is that it's radioactive.
Oh.
Right, and you don't want to. It's a very big atom right down the bottom there,
Like
and those big atoms tend to be very unstable. So you don't want to be doing this and spouting radioactive gas and substances into the air. So nobody, I don't think, has really done it.
And isn't there only like 25 grams of
Oh, wow,
francium
like
in
it.
It's
the world?
extremely rare, yeah, extremely rare. Because you can understand why it's very reactive. Okay, it's very difficult for it to exist in large amounts anywhere. There's no use for it. Okay, and it's very heavy, so it probably does exist in compounds, but probably close to the centre of the Earth.
Sir, why does it look purple down there, but it doesn't look
Purple
all
on
purple?
top, because that's where it's reacting. So all the water is just changing up the top there. Alright, okay, I'm going to have to get you guys to stand back again.
How come it's swirling into the middle? Well, if you look, it looks like
Yeah, it
it's
does
swirling.
too. I don't know why. I don't know why. It's very pretty though. Alright, here we go. Just potassium water.
And it's stuck.
Can't you touch it? Why?
It scared me for some reason, I don't know why.
Whoa.
Alright, so a lot more reactive. What I'm going to do now, just really quickly, is I'll take all three and put them all in together.
Oh, yeah.
Put on filter paper.
You've done that last time.
On filter paper, it tends to be quite spectacular
Why did you have to wipe off
because.
the oil?
Sorry?
Why did you have to wipe off the oil?
Because we want it to be exposed as much as possible to the water, because that's what it's reacting with.
With potassium, wouldn't that set the filter paper on fire?
Yep, hopefully that's the case.
Oh.
Alright, because it gets, you can see how hot potassium gets.
Yeah.
Okay, I'm going to try and get some pieces of a comparable size. Alright, what's that one? Potassium.
They're like a medicine tablet pop.
Alright, that's a little bit too big. We'll cut that one down a bit.
What's it proper famous?
Yep.
Well, I get really annoyed when people go strong and lose.
That's very nice.
How's it spelled? Aaron, double A, double R.
Don't you get annoyed when you go
Sorry, one R.
Don't you get
Problem with Aaron is there's so many ways you can spell it.
So I'm gonna need like to swap out for me.
I used to get really annoyed when people used to spell my surname wrong.
Victoria.
It's got an E on the end.
Paul.
a silent T?
That's right.
Don't you miss us, sir?
Yeah.
I don't know what that is.
We should kick
Aaron out.
That one.
What's that? Do you know?
That was the first one.
Excellent. That's right. Another distinctive thing you notice about the flame of potassium. What colour was it?
Purple.
Purple. Good.
So, are these all magnetic then? Because they're metals.
I've missed it ages ago.
Not all metals are magnetic. Are they attracted to a magnet though? I don't know. I imagine they would be.
Try it.
Attracted. Would these be attracted? Could we attract a magnet to them? Alkaline metals. I don't know. Do you know what? I've never tried.
Why don't you get
Should
a
we try?
magnet?
No, I'm trying. Let's just try it.
Yes, he does.
Yeah, I think so. We'll just check.
Yeah, it's very easy to
And
then you die and it makes
we will get people to stand back when I do it because again I've never done it before and I haven't actually done
So
it.
what about
Is that can we turn up? Actually, I haven't done a risk assessment on it. I don't even know exactly what's going to happen. Is that still on?
Yep.
Yeah, who cares about risk assessment?
But we can cut it afterwards. Edit it. Quick
I
size.
don't. Why are you wearing it like that? Because for later, I just thought it.
Alright, we'll leave that. We'll do it with these while we've got this out. Okay, but we have lithium, sodium, potassium right there in order. Thanks, miss.
Stand back, everybody.
No.
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 Try the other side. It may
Yeah.
be the wrong side.
The other side of the magnet shouldn't make any difference. I don't think.
Although it's an opposite charge.
Yeah.
Nope.
Nope.
He said.
Oh, good. Learn something every day. It's a good day there.
I've never
It's a good day.
actually heard of a metal that's only attracted to a
Have you done this
certain
before, sir?
form
Yeah, I do this all the time.
Yeah, he done it last time. Can't you remember?
I don't
Okay.
know.
Oh, I don't remember
No,
that,
you
yeah.
weren't. You never came.
Well, I'm here now, aren't I?
Unfortunately.
What happened if you touched it?
Yeah.
Nothing much. It's just you got moisture on your hands,
Oh yeah.
so we try to avoid touching it as much as we can. Okay, so here we go. Here, guys, lithium, sodium, potassium in order. All right, here we go. I'm going to put that into the water just like that, just to show how reactive they are.
Wow.
So notice the flame of the sodium. That's the sodium in the center. Notice the flame color. Very bright orange, isn't it? It's very unpredictable, and I actually do sometimes get a little bit nervous when I do that. And the lithium just sort of sits there and fizzles away happily.
Oh, that stinks. So, if I go have a drink, let's all go have it right over there.
Yeah, of course you can.
Boom.
Yeah.
And there it goes. It just happily fizzles away. I'm really not sure what that smell is. It should smell hydrogen gas.
Perhaps it's just not sustainable.
Yeah.
Makes me cough.
That's my